Yo, 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 this is Mr. O. And for today, we're gonna try to graph and analyze the characteristic of a polynomials. Before we go to the characteristic of polynomials, let's try to review about the end behavior of a polynomial. When you say end behavior, it's where the behavior of the arrowheads or the ends of the graph goes. For example, if we have a graph that goes like this graph here is an odd degree function. How did I know it's an odd degree? Because if the arrowheads are split, meaning say one is going up, one is going down, if you look at the arrowheads here, this one here is going down, this is going up, it's an odd degree. If I reverse it, and I get something like this is still another odd degree because the arrowhead are split. This is going up, this is going down. So what is an even degree? An even degree will be the one like where the end behavior are pointing the same direction, like this. So again, if you compare them, the odd degree will have split. One is going down, one is going up, or it can go up and down. Unlike with the even degree, both arrowheads are pointing the same direction. These are both pointing up, these are both pointing down. How do they differ? So look at this one here. For the odd degree, the graph is started lower and ends up going right. When you read the graph, you look at it from left to right. This is going up. So I know that the leading coefficient here is positive. Unlike here, again, you read from left to right. It started very high and it's going to end low. This is going down. So the leading coefficient here is negative. For the even degree, it's pretty obvious that both arrowheads are pointing up. So that's why the leading coefficient here is going to be, or it's a positive. Here, both arrowheads are pointing down, so the leading coefficient here is negative. This graph here is going to the left side of the x, so that means x, or as x approaches the negative infinity, because the x is going to the left. What happened to the function? What happened to the f of x, or what happened to the y? As the x goes to the left, the graph goes down, so the y is approaching the negative infinity of the y. And on the other side, as you go to the right side of the x, so as x approach the positive infinity, because right side is the positive, that's going towards the positive infinity of the x. What happened to the graph? The graph is going up. If the graph is going up, the f of x is approaching the positive infinity. Let's look at this one here. So here, on the left side, so when you say the left side, that is as x approach the negative infinity. What happened to the graph? The graph is going up, so the f of x is approaching the positive infinity in terms of y. On this arrowhead here, the graph is on the right side, so as x approaches the positive infinity, what happened to the graph? The graph is going down, so f of x is approaching down, so it's approaching negative infinity. Let's try the even degrees. This is going up, but that's on the left side of x, so as x approaches the positive infinity, or the negative infinity, because it's going to the left, that's negative infinity, the f of x is going up, so it approaches the positive infinity. Going to the right side as x approach the positive infinity because going to the right, the f of x, what's happened to the y? The y is going up, so it approached the positive infinity. If you notice, both of them are, the y are approaching the positive infinity because both of them are going up. So when we look at the even degree for negative leading coefficient, as x approaches the negative infinity, that means it's going to the left of the x-axis. What happened to the graph? The graph is going down. The graph is going down, so therefore the f of x is approaching the negative infinity. As x goes to the right side, it approaches the right side, so this time the f of x is approaching the negative infinity. Degree with a leading coefficient of negative 2. So 8 degree is an odd number. That's an odd, 8 degree is an even number. Sorry, I'm losing time here. 8 degree is an even number. So if that's even number, eight degree is an even number. So it's either both of them are pointing up or both of them are pointing down. But the leading coefficient is negative, so therefore they're pointing down. So my end behavior will be similar to this one here. Okay, so first let's have our problem. So our first problem here is y is equal to x cubed plus 5x squared minus 5x plus 7. Type x cubed, which is right here, to the third power, caret, third. Hit right side, 5x squared minus 5x plus 7. Okay, I'm going to graph it. And when I graph it, you don't see the entire graph as of now. Okay, you don't see it right now. Okay, so what you need to do is, I need to see the top portion of my graph because it's kind of cut off here. I expect that there should be more up here. So I'm going to hit the window. I'm going to hit the y max because the problem here is that I need to make the y value bigger. So I'm going to hit the window, y max here. The y max will be like, if it's 20, I'm going to put 50 there, graph. There you go. I can see now the entire graph here, right? Okay, so if I can see the entire graph now, I will find some important points. So let's have to graph it first, okay? First thing you need to know, the last number there is 7. I know that's the y-intercept already there. So 1, 2, 3, 4, 5, 6, 7. I know the point goes there, okay? Review. Is this an odd or even degree? It's an odd degree. What's the leading coefficient? It's positive 1, right? So it's positive 1. We expect that it's going to be something like this. It starts from the bottom left and goes high on the top right. And it manifests in our graphing calculator that it starts going down and go back up here. So what are we going to do now? So first, we have to find our relative maximum and relative minimum. What's the meaning of relative maximum minimum? Those are the turning points of our graph, wherein you can say it's the vertex on the max and mean of the parabola. If I cover this portion here, you can see like a parabola here. That's my vertex there. That's my maximum. And on this side here, that's my minimum. So I need to point those tip or the bottom portion of my turning points. So what I need to do, since I'm going to start this one here first, that's my maximum. So I'm going to go second trace. Since that's maximum, I'm going to go down, go to the 4, enter. And it's asking you for the left bound. I'm going to bring the spider, the blinking point, right on the left side of the vertex or the maximum, somewhere here. Enter. Then go right down. It's being asked, go to the right side. Anywhere there. As long as you pass that vertex, enter. Enter again. That gives us negative 3.7 for 3.3. So that means on the negative 3, 1, 2, 3, 4, this negative 3 point, this negative 4, this negative 3, somewhere here, up here, you know, let's say that point there, that is 43.3. So there's a turning point right there. So the graph goes this way. And then gonna come down here, somewhere here, okay? Now, let's find the other point here. The other point here is the minimum. So I'm gonna go to second trace. Second trace, I'm gonna go to the minimum. And the minimum point is right here. So I need the left bound. So the left point of the spider, anywhere in the left side. Enter. And I'm gonna go right bound anywhere on the right side of that. Enter. Enter again for the third time. Minimum is 0.4 and 5.8. So 0.4. 0.4 is somewhere here. Let's say this is 0.4. And 5.8. 1, 2, 3, 4, 5. Let's say this is 5 here. So the graph picks up from here. Okay. So this is 5.8. Okay. So let's start now here. So if you're being asked to find the relative maximum, you have one relative, we have a one over here, that's a max. And the point of that one is negative 3.7 comma 43.3. And this point here is 0.4 comma 5.8. That's the minimum, right? Now, how do you find the relative minimum maximum? That is our relative minimum, maximum. This is our relative minimum. So it will be negative 3.7 comma 43.3. And our relative mean is going to be 0.4, 5.8. Okay, there you go. So as we find the EB, what's EB again? The end behavior. Since we know the graph is falling on the left side, so as x approaches the negative infinity, because this graph here is on the left side of x, is going on the left, that's the negative infinity. What happened to our f of x? The f of x here is going to the right side, is going down. The y is going down here, so this is approaching the negative infinity. As x approaches the right side or the positive infinity, what happened to our arrow here? It's going up, so this is going or approaching the positive infinity there. And that's how you find the end behavior. Now, there's an increasing interval and there's a decreasing interval here. How do we know the increasing and decreasing? Okay, let's analyze the graph here. The increasing is when it's going up. This portion of the graph, the yellow one, the highlighted one, it's going up. So that is increasing. And likewise here, this is also increasing. Do you agree? So how do we write the increasing interval? If you start, when you read the increasing interval, you always read the x value. And we know that this one here is starting not on the negative 6 or negative 7. It started on the left further, which is the negative infinity. So from negative infinity, it's going to stop increasing right here. But right here, the x value is negative 3.7. Remember, we are only reading it through the x values. So from negative infinity to negative 3.7, that's the increasing interval. It doesn't increase anymore as it keeps going to the right. So the increasing interval is from negative infinity to negative 3.7, comma. And is that the only time that the graph is increasing? No, it's also increasing right here. The x value here is 0.4. So here I'm going to say end or 0.4 because the x value there is 0.4. And that keeps going up until further right, which is going to the infinity, comma there. If you notice, my answer are all parentheses. There's no bracket here. The reason for doing that one is that they do not increase anymore when it hits negative 3.7 because it stopped there. It stopped going up or down here. It's even. It's going to be 0 there. So that means you do not include negative 3.7 and 0.4 there. Okay? So when does it decrease? It's decreasing right here. It's decreasing over there. So if it's decreasing right there, where does it start? It starts from, what's the x value here? Again, it's negative 3.7, comma. And that is stopped decreasing at 0.4, parentheses. And that's all it becomes decreasing. And that's how you describe identify the characteristic of this polynomial. If I may add here, the y-intercept here will be 0, 7 because the last number there. Okay, there you go. Domain and range. Let's do domain and range here. Domain. What's domain here? Since the graph has further on the left, the graph has further to the right, it's going to be all real numbers. And the range here, we have a graph going down to negative infinity. We have a graph going up. So the domain there is, the range there is also all real numbers. Or we can say from negative infinity to positive infinity. And that's how you graph and identify the characteristic of this function. Let's do one more. All right. So again, we're going to use our calculator to graph this. And I'm going to ask you to use your calculator. You're going to hit the y equals. You're going to clear it. And I'm going to type in the function negative squared minus 2x plus 1. There you go. I'm going to graph it. Oh, there you go. Very nice. Okay. It's kind of cut off the top portion of one of the relative maximum here. So what I'm going to do here is that I will raise the y value. So I'm going to go window. Y max will be there, 50. So I might add another 25 there. Graph it. Hopefully I have enough. Boom, boom. Very good. There you go. I have the entire graph there. So let me draw. I know here that it's an even degree because the degree is fourth. The leading coefficient is negative. That's why they're both pointing down, right? If they're both pointing down, we can say that our graph here are falling on left and right side. So both functions are approaching the negative infinity. We will write the end behavior in a while. So we're going to find the graph here, the relative max and relative minimum. In our graph, how many relative max do we see? If you say 2, yes, you're right. There are 2 relative max there. And there's only 1 relative minimum. So how do you find the relative max? We're going to hit second trace. Go to the max, 4. And left bound, we're going to go on this point here. On the left of this point. So I'm going to pass it a little bit. Enter. Hit the right cursor. Going to pass the right bound. Enter, enter. That give me negative 1.6. So negative 1.6, comma 15.1. If you notice, I'm just rounding up nearest tens. And let's go with another relative max here. So second trace, max again. So I'm going to go to the left side. That's the left side. Enter. Go to the past the vertex. Enter, enter. That gives me another one here, which is 3.1, comma 58.1. Okay. And then the relative minimum, I'm going to second trace, go to the minimum, number 3. Go down, go to the left bound of that vertex, of the turning points. Enter, right cursor, enter, enter. So the minimum is 0.1, comma 0.9. There you go. And there's only 1 relative minimum here, okay? So let's try to plot the points here. So I have negative 1.6 right here. That's negative 1.6 and 15.1 approximately. Let's say this is 15.1 here. So let's say the graph is right there. And we have 3.1, let's say 3.1, this is 3.1, and 58, let's say it's the highest possible there. Let's say, there you go, that there is 58.1. I have 0.1, 0.9, 0.1, and 0.9 right here. That's 0.1, and this is 0.9. Okay. Another thing that you have to remember that your y-intercept here is 0, 1 because this is 1 here, the last number. So it's going to cross this point here. So, and we know it's even degree, negative coefficient, so it falls down, falls down. So I'm going to show that this is dropping down here. And it's going to cross those points and go back up high there in 58.1 and come down. And boom. All right. And that's my graph there with the relative minimum maximum, including the y-intercept. All right. So what else do we need to know here? So we have to find out the EB, the end behavior. As x approach, the x is going to the left. That's going to negative infinity. The f of x is going down. So that's going to the negative infinity. As x goes to the right side, so that means as x approaches the positive infinity, what's happening to our arrowhead is going down, so the f of x is approaching the negative infinity also there. Okay? Now, how do we find the increasing interval and decreasing interval here? Okay? So again, they are going up here in the highlighted yellow one and here. Those are increasing. Okay? If that's increasing there, so it started not somewhere here negative, but completely in the negative infinity. So from negative infinity up to the x value. What's the x value here? Remember this point here is negative 1.6, comma 15.1. And this point here is 3.1, comma 58.1. So we only look at the x value. So it starts at negative infinity, go to negative 1.6, parenthesis, and it starts here again in 0.1, 0.1, going to 3.1. That's where it's going up. While decreasing, it's going down right here and right there. If it's decreasing there, it decreased started at negative 1.6 because this is the x value there, negative 1.6. What's the x value here? This is 0.1, 0.9. So that's going to be up to 0.1 parenthesis. And the x value here is 3.1 going further to the right side. This is right side of the x to the positive infinity. Okay? And again, your domain and range here, domain and range. For the domain here, since you have a graph on the left side, you have a graph on the right side, that's going to be from negative infinity to positive infinity or all real numbers. And the range here, this is a tricky portion, the range. When we read the range, you start from the lowest point. The lowest point here is the negative infinity. The highest point here is the y value, which is 58.1 bracket. Okay, it's bracket because that's the highest point of the y value. And that's how you graph function and identify its characteristic. As always, kaboom!